Hello. In this video, we compare business analytics with big data analytics. Today, companies have an abundance of data, but it can be difficult to know how to interpret all that data. One method that has helped make that task more manageable is using big data analytics. Let us take a look about big data analytics. Big data analytics are not only about analyzing data. Big data analytics are advanced analytics that collect, organize, and analyze big data for relevant information. The aim is to find patterns and correlations that can help managers making better decisions. Ultimately, the goal of big data analytics is to find all the knowledge that the data can provide for a company. We use big data analytics to sift through a large amount of data that can come from a variety of sources like transactions, web servers, social media, surveys, and even emails to find hidden patterns, or more precisely, hidden predictive patterns. Big data analytics describe the data sets and analytical techniques and applications that are so large, from terabytes to exabytes, and so complex, from sensor to social media data, that they require advanced and unique data storage, management, analysis, and visualization technologies. Historically, we can distinguish two periods of evolution. The first period starts in the late 2000s. Business analytics was introduced to represent the key analytical components in BI, business intelligence. The second period started around 2006 with the web intelligence and web analytics. It was the period of Web 2.0. Let us compare these two periods. Business intelligence traditionally focuses on using a consistent set of metrics to both measure past performance and guide business planning, which is also based on data and statistical methods. It relies heavily on various data collection, extraction, and analysis technologies. Data warehouse combine mostly structured data via extracting, transforming, and loading, ETL, extracting, transforming, and loading processes. ETL, extracting, transforming, and loading, allows for refreshing and updating operational databases into the relational database management system. Data warehouses are then available for queries through dimensionless objects such as cubes. Once the information is captured and stored in data warehouses, the data analyst may perform online analytical processing, OLAP, creates business reports. He can visualize data and produce operational and business intelligence. OLAP summarizes data and makes forecasts. Data mining discovers hidden patterns in data and operates at a detailed level instead of summary level. Structured Query Language, SQL, is a software program which can be used to create databases, store and update data in these databases, and retrieve information from them. The nature of data capturing and processing has changed dramatically in the era of big data. The certain drawbacks of the previous era became more prominent by the day as companies stepped out of their comfort zone and began their pursuit of a wide approach toward attaining a sophisticated form of analytics. The big data analytics is composed of data sources, data storage, and advanced analytics. All big data analytics starts with one or more data sources, including internal and external structured and unstructured data, such as the static file produced by applications, such as web servers, log files, and real-time data sources, such as Internet of Things devices. All kinds of data in motion, in rest, and many different forms are considered in big data analytics. Customers, surprisingly, did not resist this new strategy of demanding of external information from external sources. Clickstreams, social media, internet, public initiatives, and all these sources of data. The need for powerful new tools quickly became apparent. Data storage. Data from batch processing operations is typically stored in a distributed file store that can hold high volume of large files in various formats. This kind of store is often called a data lake. Options for implementing this storage include Hadoop Data Lake, for example, or Azure Data Lake Store that serve as the primary repository for incoming streams of data. In such architecture, data can be analyzed directly in a Hadoop cluster or run through a processing engine like Spark, for example. Non-structured query languages, non-SQL, have emerged and their respective non-relational databases have been used in real-time web application. While relational databases consist of related tables, records, and fields, non-SQL databases contain non-structured data in the form of key values, graphs, and documents. Sound data management is a crucial first step in the big data analytic process. Data being stored in the Hadoop distributed file system, for example, must be organized, configured, and partitioned properly to get good performance. Advanced data analytics is the third and final part. Once the data is ready, it can be analyzed with the software used for advanced analytic processing. That includes tools for data mining, which sift through data sets in search of patterns and relationships. Predictive analytics, which build model to forecast customers' behavior and other future developments. Machine learning, which taps algorithms to analyze large data sets. And deep learning and artificial intelligence. Text mining and statistical analysis software can also play a role in the big data analytics process as the mainstream BI software and data visualization tools. Technology terms continue to change and evolve with new trends. The terms business intelligence and big data analytics are both terms interrelated and overlapping each other in certain areas. However, there are distinctions that help classify the two. Business intelligence can be viewed as using business data to understand a company's past and present, while big data analytics can be viewed as using big data to look ahead into the future. Business intelligence queries answer basic questions about business operations and performance, such as what happened? Why did it happen? Business intelligence tries to identify current problems and determines how to resolve them using tools such as reporting, dashboard scorecards, all up online analytical processing, precisely slice and dice and cubes, ad hoc queries, and operational and real-time BI. While big data analytics try to identify potential issues and determine how to avoid them using a form of advanced analytics. It answers complex questions such as, why did it happen? Will it happen again? What will happen if we change it? What else does the data tell us that we never thought to ask? Big data analytics improve the strategy for moving forward. It involves complex applications with elements such as statistical and quantitative algorithms, machine learning algorithms, artificial intelligence, data mining, predictive modeling, and they do also text analysis. And there is also the if analysis powered by high-performance analytical systems. BI is a reactive approach. It measures the past performance by explaining the causations. What happened? Why this happened? It focuses mainly on descriptive analytics and diagnosis analytics. So it analyzes structures and cleans data using simple methods. Dashboards, scorecards, these are limited data sets. But big data analysis is a proactive approach. It analyzes a large scale of data sets. It predicts what will happen and describes what to do. It focuses more on predictive and prescriptive analytics. So it deals with structured but also unstructured data to simulate and optimize. Both business intelligence and big data analytics has in common what you call business analytics. What is business analytics? Business analytics refers to the use of data, information, technology, computer-based models, mathematical quantitative methods, and statistical analysis for a continuous iterative exploration and investigation of data to gain insights and drive business actions. 4 types of data analytics can be done: descriptive, prescriptive, diagnosis, and predictive. Descriptive analysis report on the past. What happened? Diagnosis analysis use the data of the past to study the present. Why did it happen? Why did it happen? Predictive analytics use insights based on past data to predict the future. What will happen? And prescriptive analytics use models to specify optimal behaviors and actions. How can we make it happen? Although big data analytics includes all the above types in a broad sense, it emphasizes the 2 last, predictive and prescriptive analytics. Business intelligence emphasizes the 2 first only, descriptive and diagnostic analysis. Both BI and big data analytics introduce the idea of automated analytics.